Hello, and welcome to this month's release of VideoTec. This month, we'll be taking a look at the premier four-wheel disc brake system. The four-wheel disc brake system was introduced on some later 1989 Premiers and will be the standard brake system on the 1990 Premiers as well as on the 1990 Dodge Monaco ES.
What we'll be covering this month is everything that's different about the system. We'll show you the unique components, the system's overall operation, and then finish up with the system's diagnosis and service. And even if you have serviced the four-wheel disc system, you'll still want to pay close attention because we'll also be showing you a few helpful hints on making the service of the system a little easier.
Right. So let's start out by showing them the individual components of the system. There are basically 6 major components that make up the four-wheel disc brake system. These are the calipers, the brake pads, the disc rotors, a proportioning valve, the master cylinder, and the brake booster. Also, the brake tubes used on this system are of the same isoflare design used in previous Premier models. Now, the four-wheel disc system features the same front calipers that are used on the conventional front disc rear drum system. They're mounted to an adapter which is bolted to the hub. These front calipers are serviceable and can be overhauled when necessary. But the rear calipers are quite different. The rear calipers are mounted to the rear knuckle, which is attached to the rear axle. These 2 slide pins are used to secure the caliper to the spindle and allow the necessary lateral movement. Even though the rear calipers have a single piston design like the front calipers, they actually serve 2 purposes. First, they act as the normal rear wheel brakes during vehicle operation. And second, they also carry out the duties of the parking brake. During normal operation, the rear caliper works the same as the front disc brakes, hydraulic pressure acting on a piston. When the brakes are applied, fluid pressure forces the piston to clamp the brake pads onto the rotor. But again, the rear calipers also house the parking brake mechanism. When the parking brake is applied, the cable will rotate the operating lever. When the lever is rotated, ball bearings will roll against a ramp, forcing the piston against the brake pads. Then, once the parking brake is released, a return spring repositions the operating lever to its original position. Now, the rear caliper is not serviceable with most of its individual parts. You can either replace the entire right or left caliper housing or a few individual parts, which include the parking brake lever kit assembly, the retention pin, the anti-rattle spring, the bleeder screw and cap kit, the brake pad kit, and the attaching part kit, which includes the primary and secondary sleeves and bushings. But at no time should you try to service the piston or internal bore components. If any caliper components that we did not just list become inoperable, the entire assembly must be replaced. Also, the removal of the rear calipers, which we'll take a look at in a few minutes, is quite different from the front calipers. Now, let's turn our attention to the brake pads. The brake pads are made of a non-asbestos material which reduces heat and wear under heavy braking, as well as eliminating your exposure to asbestos. As you can see, these rear brake pads are identical. Their design is symmetrical, so you don't have to worry about which pad attaches to which side of the caliper. However, it's important to note that these rear pads are not interchangeable with the front brake pads. The pads are attached to the retaining pin, which holds the pads in place and allows them to be tightened around the rotor. Okay, our third component is the disc rotor. You'll notice that the Premier uses two different kinds of rotors. The vented rotor, the one with the slots in it, is used in the front. This venting is needed to keep the rotors cool because the front brakes handle 60 to 90% of the vehicle's weight during braking. The rear rotors, on the other hand, are solid and about half as thick as the front vented rotors. Both rotors have their minimum thickness tolerances stamped into their hubs. Now, let's talk about the brake components located inside the engine compartment. Later 1989 models and all 1990 models feature a specially calibrated proportioning valve. This valve is different from Chrysler valves because it only has two outlet ports and does not diagonally split the brake system. Only fluid going to the rear brakes is channeled through the proportioning valve. The valve limits the hydraulic pressure fed to the rear brakes, giving optimum front-to-rear brake balance without premature rear wheel lockup. This provides balanced braking action during high and low pedal effort. Refer to the Premier Service Manual for all service information. Okay, our next underhood component is the master cylinder. The master cylinder is of a cartridge type with a split reservoir and is the same cylinder used with the disc drum brake system. You can see here how there are not two, but four outlet ports coming out of the master cylinder. The reservoir is split so that half of the brake fluid goes through the primary brake lines, which are the left front and right rear brakes, and half goes through the secondary lines, which go to the right front and left rear brakes. This ensures that the vehicle can still be stopped if partial pressure loss occurs. Now, the master cylinder is serviceable, but only for a few parts. The cylinder and reservoir are available both together and individually, and you can also service the cap, diaphragm, two seals, and washer. If any other components are faulty, the entire component must be replaced. Now we're up to our last major brake component, the power brake booster. The brake booster is the same type of booster used on the disc drum systems, but it is not interchangeable with 1989 vehicles because it features a different push rod than 89 models. This booster is the same kind that has been used on Chrysler vehicles. It has a dual diaphragm for better power assist, but it is not interchangeable or serviceable and must be replaced as a whole part if it is faulty. Also, there is a new pin and clip design for the connection between the brake pedal and the brake booster, which is covered in detail in the service manual. Well, that does it for the individual parts of the system. All the components we just showed you, from the master cylinder and the brake booster, through the proportioning valve, and down the brake lines to the individual calipers, pads, and disc rotors, make up the Premier four-wheel disc brake system. Well, Tom, now that they know the major components of the system, why don't you take them through the service of the system?
Sounds good. But before we show you the unique service points of the Premier four-wheel disc brake system, let me cover a very important point. When servicing this system, or any brake system, you should never use fluid you've bled out of the system, or any fluid that's been exposed to air, or fluid not meeting SAE or DOT3 standards. Any of these types of fluids aren't good for your brake system because any kind of contaminant, whether it be dirt or moisture, can cause brake system problems. Remember, use only DOT3 or SAE approved fluid, like this MOPAR fluid. Okay, now let's get on with the unique service points of the four-wheel disc system. When servicing the four-wheel disc brake system, you should first follow the diagnosis procedures in the Premier Service Manual. The manual covers everything you need to service the system. Also, TSB 55389 covers all the unique diagnoses and service points of the system. But there are a few things within those procedures that are very important. And that's what we're going to show you now. What makes the service of the system different is the new rear caliper, which is what we'll be concentrating on the most. Now, service of this can be broken into 5 different procedures. There's brake pad replacement, caliper replacement, caliper bushing replacement, rotor service, and parking brake cable adjustment. To save time, we've already removed the wheel. Following the procedures in the service manual, our first step is to remove the operating lever return spring. To do so, dislodge the spring from the caliper with a screwdriver. Next is to remove the bolt holding the operating lever to the caliper. But before you remove the operating lever, put a chalk mark across the lever and the drive disc to mark their position. This will give you the same tension setting when you reinstall the lever. Then you can pry the lever off with a screwdriver. If the return spring is warped, bent, or distorted in any way, it must be replaced. With an Allen wrench, remove the upper slide pin. This is the pin located above the piston. Then, loosen the lower slide pin with a wrench and tilt the caliper downward on the rotor. Now, this is all very different than what you're used to servicing, so pay attention. With a pin punch, remove the brake pad retaining pin. Check the condition of the pin. If the pin is corroded or if the sleeves are worn or damaged, replace the pin. Remove the lower slide pin, lift the caliper off the rotor, and remove the brake pads. As with any brake caliper, you shouldn't allow the brake hose to support the weight of the caliper, so suspend it from the axle with a wire. Then remove the rotor so that it isn't in the way when it comes time to reseat the caliper's piston. Carefully inspect the upper and lower slide pins, their bushings, and the lower slide pin's boots. If they're corroded or worn or damaged in any way, replace them. Also check the caliper itself. If there's evidence of any leakage or if the piston or its dust boot is damaged, the caliper must be replaced. If the caliper checks out, disconnect it from the wire and mount it onto the knuckle with the slide pins. And now we're up to a very important procedure, the seating of the piston. It's important that you do not use a C-clamp as you're used to. Using a C-clamp could easily damage the parking brake mechanism, making it inoperable. Attach spanner tool 6366 onto a 7/16" deep well socket extension. Insert the tool into the matching piston holes and rotate the piston clockwise until it's fully bottomed in the bore. You'll have to place quite a bit of inward force toward the piston to make sure it gets seated. Then take out the slide pins, remove the caliper, and secure the rotor back onto the axle hub. Install the new brake pads into the caliper, making sure they're properly fit, and then finish by installing the caliper onto the knuckle. When installing the slide pins, tighten the small upper slide pin to 32 Newton meters, or 24 foot-pounds of torque, and the large lower slide pin to 52 Newton meters, which is 38 foot-pounds. Once the slide pins have been installed, be sure the anti-rattle spring gets positioned so that the brake shoe retaining pin will go through both the pads and the loops at the end of the spring. Now we can reset the parking brake cable, lever, and spring. But it's important to note that the squared loop of the return spring goes on the caliper and the rounded loop attaches to the operating lever. That will ensure that the spring applies the correct tension on the lever. So before you install the operating lever, place the return spring onto the caliper. Then place the operating lever onto the parking brake cable. Then pull the cable rearward and install the lever onto the caliper, matching up the chalk marks that we made earlier. If you don't match the chalk marks, the spring tension will not be correct, and the parking brake will either be too loose or too tight. The next step is to install the spring. Now, this final step is very important. After the wheel has been installed and the car has been lowered, you have to apply the brakes several times. This will seat the brake pads and equalize the parking brake adjustment. And it's very important to check the master cylinder reservoir to make sure the fluid is up to the bottom of the filler neck. Okay, Our next procedure is the replacement of the caliper itself. Now, most steps in this procedure are the same as we just showed you. The only major difference concerns the brake hose. After you've attached the new caliper, which includes lubricating the caliper's bushings and pins with silicone, you've got to reattach the brake hose. To do so, position 2 new seal washers onto the hose fitting, one on each side of the fitting block, and connect the fitting to the caliper. Then, torque the fitting bolt to 40 Newton meters, or 30 foot-pounds. Now remember, after the vehicle's been lowered, you'll have to bleed the brake system with a pressure bleeder. It's important that this be done after the vehicle has been lowered, because the rear axle must be at normal ride height so that air doesn't get trapped in the system. And again, make sure there's plenty of brake fluid in the master cylinder after you're done bleeding. Okay, we're up to the caliper bushing replacement. After the caliper has been removed, as we just showed you, discard the original slide pins and push the bushings and boots out of the caliper. The bushings are slip fit and should dislodge with finger pressure. If they're tight, you can carefully tap them loose with a mallet. Clean the bushing boards with brake cleaner and a wire brush, and lubricate the new bushings with silicone. Then assemble the bushings and install. It's easiest to push them in from the bottom. And when reinstalling the caliper, just remember to use new slide pins, because the slide pins come with Loctite already applied. And installing new pins will ensure that the pins will hold properly. Our fourth procedure is the servicing of the brake rotors. The rear disc rotors can be sanded and/or machined to restore surface flatness and finish. However, if the surfaces are severely worn, scored, tapered, or out of tolerance, they must be replaced. The minimum allowable thickness for the rear disc rotor is stamped into the reverse side. In this case, it's 9.5 millimeters, which is 374 thousandths of an inch. The maximum allowable runout for the rear rotor is 8/100ths of a millimeter, or 3/1000ths of an inch. If the runout is in excess of this, the rotor must be replaced or machined, and there's no difference in the removal of the rotor than what we've already shown you. But again, don't forget to reseat the caliper piston and apply the brake several times to adjust the piston to the new disc. Okay. Our last service point concerns the adjustment of the parking brake cable. As Bob explained earlier, this rear caliper has the integral self-adjusting parking brake feature. Adjustment of the parking brake due to pad wear isn't necessary, but you may need to adjust the cable because of stretch or deterioration. The parking brake cable adjustment is the same as with previous Premier models, where you adjust the cable at the equalizer. Again, all this is covered in both the Premier Service Manual and the TSB number 55389. Remember, what we've shown you here are just the things that are different about the Premier four-wheel disc brake system.
That's right. Everything else, including the service of the master cylinder, brake booster, proportioning valve, and the front calipers, is the same as the disc drum Premier models. Well, we've covered a lot today. Why don't we take them through a review?
That's a good idea.
The components which make up the Premier four-wheel disc brake system are the split reservoir cartridge-type master cylinder,
the dual diaphragm vacuum power brake booster,
the specially calibrated proportioning valve,
the calipers, which include the unique dual-function rear calipers,
the front and symmetrically designed rear brake pads,
and the vented front and solid rear disc rotors.
We hope we've given you a good look at the new four-wheel disc brake system, now standard on the 1990 Premier.
It's very important that you know the differences between this system and the disc drum brake system.
That's right. Just follow the diagnosis and service procedures in the Premier Service Manual, and review this release when needed, and you shouldn't have any trouble. Keep up the good work, and we'll see you next month on VideoTec.